The Sukhoi Su-57 Felon is Russia's answer to Western fifth-generation fighters. While its initial production models have been flying with an Interim engine, the development of a truly fifth-generation powerplant, known as Izdelie 30, manufactured by UEC-Saturn, is critical for the Su-57 to achieve its full design potential and be considered a true fifth-generation fighter. Before delving into Izdelie 30, it's important to understand what the Su-57 is currently using. Early and initial production Su-57s are powered by two Saturn AL-41F1 engines. This engine is an advanced derivative of the AL-31F engine found in the Su-27 family, and a direct evolution of the AL-41F1S, product 1117S, used in the Su-35S. The dry thrust would be approximately 93.1 kN, while its afterburning thrust is approximately 147 kN. It features a FADEC, full authority digital engine control, system and 3D thrust vectoring nozzles. However, the AL-41F1 falls short of true fifth-generation requirements, particularly in sustained supercruise capability, supersonic flight without afterburner, and specific fuel consumption, which impacts range and operational cost. It also has a larger radar cross-section, RCS, from certain angles compared to a purpose-built fifth-gen engine. Let's now explain in detail the new and upgraded Su-57 engine, the Izdelie 30. The Izdelie 30 is the definitive next-generation engine specifically designed for the Su-57, and its integration is seen as the final step in solidifying the Su-57's fifth-generation status. Testing of this engine began in December 2017 with prototypes installed on the Su-57. New features of the Izdelie 30 engine. 1. Greatly increased thrust. Izdelie 30 offers substantially more thrust than the AL-41F1, both dry and with afterburner. This translates directly into superior acceleration, climb rate, and overall maneuverability. Initial estimates suggest a boost of 15–20% over the AL-41F1. Its estimated dry thrust is approximately 107–110 kN, while its estimated afterburning thrust is approximately 176–196 kN. 1. True supercruise capability. This is arguably the most critical new feature. Izdelie 30 is designed to allow the Su-57 to sustain supersonic speeds, typically Mach 1.5 to 1.8, without engaging the fuel-guzzling afterburner. This significantly improves combat radius, endurance, and allows the aircraft to engage and disengage targets more rapidly. 1. Improved fuel efficiency and lower specific fuel consumption. Through advanced aerodynamics, new materials, and a higher bypass ratio, Izdelie 30 achieves significantly better specific fuel consumption. This directly increases the aircraft's range and loiter time, reducing reliance on aerial refueling. 1. Advanced materials and manufacturing. The engine incorporates new generation composite materials, ceramic matrix composites, CMCs, and advanced alloys capable of withstanding higher temperatures and stresses. This contributes to lighter weight, increased durability, and greater reliability. 1. Reduced radar cross-section, RCS. While exact details are classified, Izdelie 30 is designed with stealth in mind. This likely includes sawtooth patterns on the engine nozzle and access panels to disrupt radar waves, radar-absorbent materials, RAM, incorporated into internal and external components. S-duct air intakes on the Su-57 itself help mask the front-on view of the engine fan, a major radar reflector. The engine's design contributes to the overall low observable characteristics. 1. Lower infrared, IR. Signature. New combustion chamber designs and potentially advanced cooling systems help to reduce the heat signature of the exhaust plume, making the aircraft harder to detect by IR-guided missiles. 1. Advanced FADEC, full authority digital engine control. A more sophisticated digital control system provides precise management of engine parameters, optimizing performance across the flight envelope, improving reliability, and facilitating seamless integration with the aircraft's avionics. 1. Modular construction, easier maintenance, faster repairs, and potentially lower lifetime costs due to its modular design. 1. Two-dimensional, 2D, or even improved 3D thrust vectoring nozzle. While AL-41F1 has 3D TVC, Izdelie 30 is expected to have an even more refined and potentially lighter thrust vectoring system, further enhancing maneuverability at both high and low speeds. Some sources speculate about a 2D nozzle for potential stealth benefits, but 3D is more probable for agility. Current status: Izdelie 30 is undergoing intensive flight testing on various Su-57 prototypes. While some production Su-57s delivered to the Russian Air Force still operate with the AL-41F1 due to the engine's extensive testing and certification requirements, the goal is to equip all future production batches with Izdelie 30. Full operational readiness for the Izdelie 30 is anticipated in the mid to late 2020s. The Izdelie 30 engine empowers the Su-57 to perform a wider range of roles with greater efficiency and lethality, fulfilling the core tenets of a fifth-generation multi-role fighter. 1. Air superiority, air-to-air combat. Supercruise mode allows the Su-57 to reach engagement zones faster, maintain energy advantage, conduct high-speed intercepts, and escape threats without draining fuel reserves via afterburners. Enhanced thrust provides exceptional acceleration and climb rates, giving the pilot an edge in dogfights and beyond visual range (BVR) engagements. Maneuverability. Combined with advanced thrust vectoring, the increased power allows for incredibly agile maneuvers, making it a formidable opponent. 1. Deep interdiction, strike and suppression of enemy air defenses. Due to better fuel efficiency, the Su-57 can penetrate deeper into enemy territory, loiter longer, and deliver precision munitions against ground targets. Stealth, with reduced engine signature, helps the aircraft evade detection while approaching high-value targets or engaging air defense systems. 1. Reconnaissance and surveillance. The ability to sprint at supersonic speeds and cover vast distances efficiently makes it suitable for rapid reconnaissance missions, especially over contested areas. 1. Network-centric warfare platform. While the engine itself doesn't directly contribute to sensor fusion, its performance capabilities allow the aircraft to operate more effectively within a complex battlefield network, rapidly reacting to threats and sharing data with other assets. The competition between these Su-57 and the F-35 is often framed as a clash of design philosophies within the fifth generation. The Izdelie 30 engine significantly sharpens the Su-57's competitive edge, but stark differences remain. The Izdelie 30 is explicitly designed for sustained supercruise at high Mach numbers such as Mach 1.5 to 1.8+. The F-35, while capable of exceeding Mach 1, is not optimized for sustained supercruise and typically achieves Mach 1.0 to 1.2 for short durations without afterburner. This gives the Su-57 a distinct advantage in kinetic energy management, rapid response, and disengagement. The Su-57, with Izdelie 30, boasts a high thrust-to-weight ratio, combined with thrust vectoring, which will likely give it superior instantaneous and sustained turn rates, climb rates, and overall agility in a close-in fight compared to the F-35, which prioritizes stealth and sensor fusion over raw dogfighting prowess. The improved specific fuel consumption of Izdelie 30 offers the potential for greater combat radius or loiter time, which can be critical for deep strike or air patrol missions, where the F-35, with its P&W F-135 engine, is designed to excel and likely retains an advantage. Overall stealth, especially at engine level. The F-35 was designed from the ground up prioritizing stealth, and its F-135 engine contributes significantly to this. The F-135 uses serpentine air intakes to hide the engine's fan blades, a major radar reflector, and sophisticated exhaust nozzle designs to minimize radar and IR signatures. While Izdelie 30 aims for reduced RCS and IR signature, the Su-57's overall airframe design, especially from certain angles, and its engine's integration into that airframe are generally considered to be less stealthy than the F-35. The F-35's strength lies in its unmatched sensor fusion, integrating data from all its sensors into a single, comprehensible picture for the pilot, and its role as a quarterback of the battlefield, sharing data seamlessly with other assets. This allows it to detect, track, and engage threats from stealthier positions, often before an adversary like the Su-57 is even aware of its presence. The engine doesn't directly contribute to this, but the F-35's design philosophy makes its F-135 an integral part of a stealthy, networked platform. While Izdelie 30 aims for modularity, the F-35's F-135 engine benefits from decades of Western logistics and maintenance doctrines, focusing on simplifying operations and achieving high readiness rates, though the F-35 program has faced its own challenges in this regard. The F-35 versus Su-57 debate boils down to an apples and oranges comparison of design. The F-35 is a true multi-role fighter designed for stealth, sensor fusion, and networked operations, aimed at achieving information dominance and first strike capability. The Su-57, especially with Izdelie 30, appears to be designed for high kinetic performance, raw speed, and agility, aiming to achieve air superiority through a combination of respectable stealth, though likely less than F-35, and overwhelming performance in a close-quarters engagement should stealth fail. The Izdelie 30 significantly closes the gap on 5th-gen performance metrics for the Su-57, but the F-35's comprehensive stealth and sensor suite remain its core strength. Implications for Russia in its quest for a true 5th-generation fighter jet. The successful development and widespread integration of the Izdelie 30 engine holds profound implications for Russia's military and aerospace industry. 1. Achieving true 5th-generation status. Without Izdelie 30, the Su-57 remains effectively a 4.5+ generation fighter, limited by its interim engine. Izdelie 30 addresses the core supercruise requirement, a fundamental pillar of 5th-generation combat aircraft alongside stealth, sensor fusion, and active electronically scanned array (AESA) radar. Its full integration signals that Russia can genuinely field a competitor to Western 5th-gen jets in terms of raw performance. 1. Enhanced operational capabilities for the Russian Air Force. With Izdelie 30, the Su-57 becomes a far more potent weapon system. Its extended range, higher speeds, and superior maneuverability significantly augment Russia's air power projection and defensive capabilities. It enables faster response times, greater threat interception ranges, and more effective deep strike missions. 1. Technological independence and prestige. Developing a wholly new cutting-edge fighter engine is a monumental technological achievement. It demonstrates Russia's ability to innovate and compete with leading aerospace nations, bolstering national prestige and reducing reliance on potentially foreign components or design philosophies. 1. Strengthening export potential. A fully capable Su-57 with Izdelie 30 on board becomes a much more attractive export option for countries seeking advanced fighter capabilities, potentially competing with Western and Chinese alternatives. This could generate significant revenue and influence for Russia. 1. Strategic deterrence. A truly 5th-generation Su-57 enhances Russia's strategic deterrence capabilities, sending a clear message about its military technological strength and resolve. It ensures that Russia can maintain a credible air combat threat against potential adversaries equipped with advanced fighters. 1. Paving the way for future developments. The technologies developed for Izdelie 30, new materials, advanced control systems, high-temperature components, can be applied to future Russian aerospace projects, including unmanned combat aerial vehicles, UCAVs, or even future-generation manned aircraft. In conclusion, the Izdelie 30 engine is not just an upgrade, it's a transformative component for the Sukhoi Su-57. It provides the essential performance metrics, particularly supercruise, thrust, and efficiency, required for the Su-57 to truly meet the design requirements of a 5th-generation fighter. Its success is paramount for Russia's aspirations in advanced military aviation, allowing the Su-57 to fulfill its designed roles more effectively and closing key performance gaps with its Western counterparts, albeit within a distinct operational philosophy.